Friends, and welcome back. So I hope based on the previous sessions you have some basic understanding of Terraform in your mind. What exactly is the Terraform and why we use it? Okay, so in this session we are formally going to introduce the infrastructure as a code like the Terraform. So what are the benefits of Terraform and why we use it, and what are some important properties of the Terraform? So what we are going to cover in this session: what is infrastructure as a code, evolution of the infrastructure management, manual versus scripted versus IaC infrastructure, benefit of IaC, immutable and mutable infrastructure, declarative and imperative infrastructure. So these are certain important functionalities, okay, with respect to your Terraform, and these are important from the interview perspective as well. So if you are going to give any of the interview, so there are a lot of questions on the like, yeah, what is mutable and immutable infrastructure, why we use it, what are the different use cases when we use these kind of approach, what is declarative and imperative infrastructure, what is the approach is followed by a Terraform. So it is very important to understand all these concepts. Now, what is infrastructure as a code? So it is very clear from the name as well. What we are doing, we are managing infrastructure as a code. So that means infrastructure as a code is the practice of managing and provisioning infrastructure using code instead of manual process. So what we have discussed so far in the previous session, we have discussed about the lot of challenges that we face due to the manual process of the infrastructure setup, which include your hardware setup, okay, and along with that the complete end-to-end software setup as well, right? So IaC is a practice where we manage the complete infrastructure using the code instead of the manual process. Okay, so instead of creating infrastructure manually in Cloud Console or servers, we write configurations files. So what we do exactly with the help of infrastructure as a code, we are doing a kind of a automation where the resources that we are going to create, suppose in the AWS console or maybe in any of the cloud service providers console. Okay, so that configurations we can do automated with the help of scripts, or which is also referred as the code. Okay, so these files can define servers, network, storage, load balancer, database, and other configurations, whatever available with the cloud service provider, or you can say whatever the services that is provided by a particular cloud service provider. All the services we can configure with the help of these automated configuration files. So the infrastructure can then be created automatically using the tool like Terraform. So we have a multiple tools others as well. So I will give you that particular overview as well. What are the other tools that is available in the market, just like Terraform, and why Terraform is the preferred tool for the infrastructure as a code. Okay, so now this is the example that we have seen in the previous sessions as well, right? With the AWS console example. Now you want to create an EC2 instance machine. Okay, so the very first thing is you have to log into the AWS console, which I have shown to you in the previous sessions as well. Then you have to create the server. You have to go to the instances EC2, then you have to select the configure instance, and then you need to provide the multiple inputs when you are configuring the machine. That means it's a completely a manual process, time taking. There would be a chance of the errors. Okay, the environment will not be consistent. Who did the changes, when did the changes, it is very tough to track, right? On the other side, if you are working with the help of Terraform, okay, so these complete tasks you can do in a single click. You don't need to do follow all these manual configurations. You can follow the Terraform scripts, and everything can be automated and can be executed within a couple of seconds. So evolution of infrastructure management. So how this infrastructure management has been evolved till the Terraform. It's very straightforward. So when we talk about the long year back, the complete where the end-to-end infrastructure management was the manual process. Okay, so there we had multiple physical servers, then we had a multiple manual installation of the operating systems, then manual installation of the softwares, then configurations, integrations, OS level configurations, application server or the software level configurations, right? So because this was the complete end-to-end manual process, so there we had a lot of challenges which we have seen in the previous session as well. It was very slow, error prone, hard to scale, hard to maintain the auditing and compliance, right? Now in second stage, it was bit increased or enhanced with the help of scripts. Okay, so what we did in that part, the administrator created the multiple scripts using the bash scripts, maybe Python, Ansible, okay, and for the certain set of automations, okay, where a lot of automations we were doing with the help of these scripts. Okay, so the improvement was bit faster automation, but still the problems was it was completely a procedural, hard to manage complex infrastructure. So it is a procedural, that means we are defining certain static scripts, okay, which we are following that to install the different kind of a set of software with the help of scripts. Okay, if the environment is getting changed or the cloud service provider is getting changed, or maybe the different set of factors are there, due to that it is hard to scale your particular scripts, okay, for the different environments, for different cloud service providers. Okay, so it was helpful in a bit, but for a large scale or for a complex infrastructure it was not feasible. And then in the stage third, infrastructure as a code came in picture, from manual to scripted, and then infrastructure as a code. So where what we are doing, we are using declarative configuration files. Okay, so configuration files means we have some static configuration files where Terraform has a syntax, proper syntax, and in that syntax we incorporate our logic, or you can say we incorporate our resources that we want to configure. Okay, so few tools like Terraform is there, and then Cloud Formation is there, and the Plumini is there. Okay, and apart from that, there are few more tools are there. I will give you a overview of that in the next sessions. Okay, so what are the benefit of this? We are getting repeatable infrastructure. Okay, so when that means if you created some infrastructure today, and again after a couple of months or a year of a time, you are going to scale your environment, and again you want to configure the same set of configurations what we have in configured year back. Okay, with the help of same set of configuration files, you can configure exactly the same environment because you have a complete end-to-end configuration files that has been used earlier, and same set of configuration files you can again use for the setup of the infrastructure. Right, you have a version control, right? So similar to the code that we have discussed in the previous session, we can maintain the different versions of the code or of the infrastructure as well. For example, we have created 4 virtual machines, okay, and we have clubbed that in the version v1. Okay, so we have tagged a version v1 to the machines that we have created today, and this particular tag has a complete end-to-end information about what is the configuration of virtual machine, what is the configuration of software, what is the configuration of different parameters. Everything is maintained in this virtual machine. Okay, and now suppose that tomorrow you are going to configure few more parameters, or you are going to update or enhance your software, you are going to enhance your some parameters in the OS level. Okay, so again you can maintain a specific version of that. So what we are doing, we are maintaining the versioning of the infrastructure as well. Okay, and this is very helpful for the audit and compliance perspective as well, right? And then we can achieving the different kind of automated deployment. So whatever the configuration that we are doing with respect to the infrastructure or with respect to the software, right, so everything we are achieving with the help of automation. That means end-to-end deployment of your infrastructure is completely automated. So these are the 3 stages, okay, of the infrastructure, right? Manual, scripted, and IaC. So manual was the initial phase, which was the stage one. Okay, it was the completely the human operations, manual stuff, right? Which was slow and error prone. Now after second stage came scripted, where we were using the shell scripts, Python, or maybe Ansible, but which is hard to maintain when the infrastructure is going to be increased and which is going to be a complex. And then now we are using the infrastructure as a code, so which is a declarative configuration. That means we declare the configurations in the multiple set of configuration files, and it is very automated and very scalable. So that means IaC make infrastructure predictable, repeatable, and automated. So the benefit we have discussed in the previous sessions, I will cover it quickly as well. So what are the benefit that we are getting with the help of that? We are getting the consistencies. That means whatever the infrastructure that has been created, okay, same infrastructure will get created next time as well. Whether you are going to create it again within a couple of days, couple of months, or a year of a time, the same set of configurations you can create every time, and the environment will be consistent across the different set of environments that you have in your particular organizations, right? So it reduces the human error because it's completely automated. We have scripts are in place, so we are just executing the script with the predefined configurations that we have used earlier as well, right? So there is a less chance of human errors. And then we have a version control. So just like we have the code maintaining with the different versions in the centralized repository, so we are maintaining the infrastructure along with all the configurations in the centralized repository. Okay, and then that means we are maintaining the different versions of the infrastructure as a code as well. So it is very easy to track the changes because now we are maintaining the complete end-to-end infrastructure information as a code. So rollback is very easy and team collaboration is very easy because the information is now in the centralized repository, right? So we can share this information and we can work in a better collaborative way with the team as well, specifically when we talk about the complete end-to-end provisioning of the infrastructure. So now it is an automation. That means infrastructure can be deployed automatically with the help of the automations, right? So the benefit are some examples like the developers can create complete infrastructure with one command, right? So now suppose that you have a developer, multiple developers, they want to create one virtual machines with some set of software for a quick testing. So, okay, so they do not have any dependency on the different set of system administrators or the cloud engineers, so that they can create the virtual machines, they can build the software, they can deploy the applications. So everything, because we have automated with the help of Terraform scripts as a code, so we can just provide a single click to the developers, and within a single click, the every complete end-to-end infrastructure will be ready within a couple of a minutes of a time. So there is no human intervention, there is no experts are required. Instead of that, your developers are doing everything within a single click, right? So you are doing a faster infrastructure deployment. Your infrastructure is getting created within a couple of a minutes, which was earlier taking a lot of hours or a day of a time. Okay, and your infrastructure is completely scalable because now everything is maintained in the code, and within a single click, your infrastructure will be ready. So whenever you have a requirement to scale up your environment or scale down your environment, you can do everything with the help of single click. Okay, and now we have a two kind of a infrastructure. One is called the mutable, and second is called the immutable. So this is very important to understand from the interview perspective as well. Okay, and along with that, you need to understand it as well. What is the mutable and what is immutable infrastructure? So what is the difference? It's a very straightforward. When we say the mutable infrastructure, so that means once the infrastructure is created with the help of Terraform. Okay, now you want to do certain kind of do a certain kind of a configuration changes. Okay, then that is allowed. What does it mean? Let me explain. For example, you have configured one server with a web server. Okay, this is a virtual machine that you have configured in the AWS cloud, which contain one web server. Right. Now suppose that you want to change some configurations of this web server, or maybe you want to change some parameters of this particular virtual machine. Okay, the earlier value was 1. Now you want to change this value to 2. Okay, in the existing infrastructure that we have already created with the help of Terraform. Okay, so if it is a mutable infrastructure, then it is allowed. That means you can change the values in the existing infrastructure. That means you have an existing virtual machine where one web server is running. So you can modify value there. And when we say immutable infrastructure, so even you need any kind of a value need to be changed here. The complete system will be destroyed. It will be destroyed and it will be recreated with the new values. So irrespective of the change, whether you have a very small change or you have a major change, like you are changing the OS version, you are changing the web server versions, you are deploying the new application, or maybe you are changing only one parameter at the OS level or maybe at the web server level, you need to completely destroy your machine and then you need to recreate it. So this is called the immutable infrastructure. Now we have a different set of use cases, like in which cases we can go with the mutable configurations, or you can say mutable infrastructure, and which cases we can go for the immutable infrastructure. So this is the scenarios where we have a mutable infrastructure and immutable. Okay. So when we say traditional application on a single server, so mutable is the best choice. Immutable is not practical because you have a traditional application where everything on a single server. So if it is a single server, then you cannot go with the immutable because it will be a downtime for your application. You have a single server and everything is running on a single server, and if you are going to destroy that machine for any set of configurations, small configuration changes, so you will have multiple outages. So this is not applicable. Mutable is the best choice in case of a traditional applications where you can change the existing infrastructure, right? Second, if you have a legacy applications or maybe some application server applications, like you have a WebLogic server, JBoss, or maybe some older applications. Okay, so in that case, we mostly follow the mutable infrastructure. We do not go with the immutable, right? Because with the application servers, we have some consistent, or you can say we have some session data is exist with each and every server. Okay, for example, if we deploy the applications in the multiple application servers like WebLogic, JBoss, WebSphere. Okay, so these are called the stateful application. Stateful applications. Other one is stateless. Okay, stateless. For example, if you have a website, simple website, where you do not have any kind of a session data. Session data in the sense, let us talk about the application server where we have a WebLogic. Okay, in the WebLogic, we have a JMS, Java Messaging System. Okay, which is used for exchanging the messages between the different application. Like suppose application A want to send the message to application B, so message is stored in your application server, right? So that means some messages are getting stored in your application server. So you cannot go with the immutable, because if you are going to immutable and you are going to destroy your machines for a small changes, then messages will get destroyed. So that means for stateful applications, we do not go with the immutable. For stateless, we can go with the immutable. Okay, so for small environments, for testing environment, your mutable is easy to maintain. Okay, when we talk about microservices, so mostly in the microservices, we go with the immutable. So because in the microservices, we do not have a very tight dependencies between your applications and the respective virtual machines. Okay, so we can easily destroy and easily create the different virtual machines wherever microservices are running. Okay, so if you have a very high available production systems, then mutable infrastructure possibly a risk. Okay, in that case, you are strongly recommended to go with the immutable. When we have auto scaling requirement, so immutable is not suitable, because you in the mutable we do the same configuration changes in the existing environment, and where you need a auto scaling environment where you need the scaling up and down very fast, we always go with the immutable infrastructure. So instead of doing the changes in the existing infrastructure, we can easily destroy the machines and easily recreate the number of machines that is required anytime. Okay, and then when we talk about the automation, where you are using the DevOps, where you are have the CI and CDs are configured. Okay, for the automated of deployment. Okay, so the preferred approach is the immutable. So these are certain use cases where you can define like where we can use for the mutable infrastructure and where we can go with the immutable infrastructure. And other important concept is the declarative versus imperative infrastructure. So we have two kinds of infrastructure, declarative and imperative. Now, what is the difference between these two approach? It's very straightforward and very simple. When we say the imperative approach, so in imperative approach, we have to explain each and every step that we need to achieve. Okay, it is similar to you are going to prepare a recipe. Okay, you are going to cook a recipe. Okay, the step one is heat pan. Second, add oil. Then add vegetables. So that means we are defining each and every step in the imperative. But when it is a declarative, you don't need to define each and every step. You need to only say the final goal, what exactly you want. Okay, so here you can see an example. I want a pizza. Simple. So you are ordering a food from a restaurant. You just say, I want a pizza. The kitchen decide how to prepare it. Terraform works in the same way. You don't need to define every step manually one by one in each and every step. You just need to define what is your final goal. Okay. Your Terraform understand your final goal, and based on that, it does all the configurations. So this is the imperative and declarative approach. So now what we are doing in imperative approach, we are defining step-by-step instructions. Create server. Once the server is created, install the software. Once the software is installed, you need to configure some network resources like the internet gateway, maybe your NAT gateway. You need to configure the security groups. You need to configure the routing tables, right? So for this imperative approach, the example tools are simple, bash script or maybe the Ansibles. Now, when we say about declarative approach, where we don't need to define step-by-step information, what we can do in that case, we can just say, I want EC2 instance, or I want a running virtual machine. Terraform automatically determine how to achieve this particular state. You are not defining the step-by-step instructions. So now that means it is very clear your Terraform is used the declarative approach. Okay, and this is the difference between imperative and declarative approach. So imperative define how to perform the task. You are defining how to perform the task, right? You are defining the step one, then sorry, you are defining step one, then step two, step three, step four. Every step you are defining, but in declarative, define what the final state should be, what exactly you want. You just need to define your goal, and Terraform will automatically understand that, and it will be ready for you. So Terraform is one of the most powerful tool for implementing infrastructure as a code. Okay, now what are the key takeaways from this particular session? Terraform or infrastructure as a code allow us to manage complete infrastructure using code. We define the different code, or you can say the different scripts. Okay, so in the next subsequent sessions, I am going to explain each and every configuration files, each and every configuration, each and every parameter in a simple way with the examples, so that you will have a good understanding of each. Right. So we are doing the automation of the complete end-to-end infrastructure provisioning. It is helping to maintain the consistency across environment. We use the version control for the infrastructure just like we use for the code, and the scaling of the infrastructure will be very easy. So these are the multiple benefits and functionalities and features of the infrastructure as a code, or you can say for the Terraform as well.